Well, welcome to GetChemistryHelp.com. My name is Dr. Kent, and in this video, we're going to work some practice problems on naming ionic compounds. Now, this lesson is a follow-up to the actual lesson on naming ionic compounds. So if you haven't watched that yet, I would suggest you watch that first. Now, you may also want to go to GetChemistryHelp.com and print out the worksheet I put together that's sort of a summary of how to name polyatomic ions. Okay, so let's go ahead and practice. Now, whenever we're going to name ionic compounds, we need to name the cation first. So the cation is always written first. So we figure out what this is called. Well, Na is called sodium. Now remember, there are two different types of metals. There are some that are fixed charge. That means they always have a set charge. And then there are some that are variable charge. The ones that are variable charge, we have to give a Roman numeral to specify which of the varying charges we mean. So let's look and find sodium. So sodium lives right here. So we said all of the ones in group 1, all of these metals are always 1 positive. All of these metals in group 2 are always 2 positive. And all of the ones over here in our magic triangle, they also have a fixed charge. So sodium does have a fixed charge, so I can just say sodium. How about phosphorus? How do we name that as an ion? Well, we learned in our lesson on monoatomic ions that when nonmetals become anions, we just change the ending to "ide." So phosphorus would become phosphide. Great, so sodium phosphide. How about this one? Cu is copper. Will copper need a Roman numeral? Well, copper lives right here, so it's not in group 1, it's not in group 2, it's not in our magic triangle, so the charge can vary, so yes, it's going to need a Roman numeral. Well, the way we figure out the charge on the copper is by looking at the nonmetal, or the anion in this case. So that's sulfur. We said sulfur just becomes sulfide. Nonmetals, the ending just changes to "ide." What would the charge on sulfide be? Well, we learned it again in that lesson on monoatomic ions that nonmetals won't have as many electrons as these noble gases over here. So sulfur needs 2 to become like argon. So it needs to gain 2 electrons, so all of these nonmetals are 2 negative. So sulfide is 2 negative, so our total charge on the anions, there's only one of them, is 2 negative. Well, the charge on the cations has to total the same as the charge on the anions. So if the anions are 2 negative, the cations have to combine to be 2 positive. But again, that's not saying it's copper 2 because we have 2 of them. So 2 coppers are combining to give 2 positive. So what would each copper have to be? Well, each copper would have to be 1 positive. So copper 1 sulfide. How about Sr? Well, that's strontium. Will strontium need a Roman numeral, or is it a fixed charge? Well, it lives right here. So it's in group 2, so it's fixed. It's always 2 positive, so no Roman numeral. Nitrogen, that's just a nonmetal making an anion, so that just changes to "ide," so nitride. Sodium nitride. Number 4. Okay, well, let's look at this one. So W is tungsten. Will tungsten need a Roman numeral, or is it a fixed charge? Well, tungsten lives right here, so it's not in group 1, it's not in group 2, and it's not in our magic triangle, so yes, it will need a Roman numeral. Well, what Roman numeral do I give it? Well, what is this? SO4, that we learned in our lesson in polyatomics, is sulfate. Sulfate has a 2 negative charge. Now we have 3 of them, so the total anion charge is 6 negative, which means the total cation charge has to be 6 positive. But we only have 1 tungsten, so that 1 tungsten must be tungsten 6. Fe. Fe is iron. Will that need a Roman numeral, or is that a fixed charge? Well, let's find iron. Oh, it's right here. It's not in group 1, it's not in group 2, it's not in the triangle, so it will need a Roman numeral. We figure that out by whatever this is called. MnO4. Well, that's a polyatomic. That's just one of the ones you have to memorize. There's not really a good pattern for it. And it's called permanganate. Well, permanganate, once we learn that, that is a 1 negative charge. There's 3 of them, so that's a total of 3 negative for the anions. So the cations must total up to be 3 positive. And there's only 1 cation, iron, so that iron must be iron 3. So So iron 3 permanganate. Ti. Ti is titanium. Will titanium need a Roman numeral? Let's see where it lives. Yep, it's not in group 1. It's not in group 2. It's not in the triangle. So it will need a Roman numeral. Well, what is BrO4? Well, we learned in our lesson on polyatomics that BrO3 negative, that's called bromate. And we also learned in that lesson that when we add an oxygen, so we went from BrO3 to BrO4, that means we add the prefix per on the front. So that's called perbromate. Well, what's the charge on perbromate? Well, the charge doesn't change. So if bromate was negative, perbromate is still 1 negative. We have 4 perbromates. That's a total of 4 negative. So we combine those. So that means the total cation must be 4 positive. There's only one of them. So the titanium must be titanium 4. So titanium 4 perbromate. But this one, Mn, well, Mn, that is called manganese. Will manganese need a Roman numeral, or is it a fixed charge? Well, let's see where it lives. Okay, it's not in group 1. It's not in group 2. It's not in our magic triangle, so yes, it will need a Roman numeral. What Roman numeral do we give it? Well, we figure out what this is called. So oxygen, a nonmetal becoming an anion. Change the ending to "ide," so oxide. What would the charge on oxide be? Well, let's see where oxygen lives. Oh, oxygen is 2 away from the noble gases, so it's going to be 2 negative. So oxide is 2 negative. We have 7 of them. That's a total charge on the anions of 14 negative. Well, that means the total charge on the cations must be 14 positive. But that does not mean that manganese is manganese 14 because we have 2 manganese combining to give me 14 positive. So what would each manganese have to be? Well, each manganese would have to be 7 positive, so manganese 7. Manganese 7 oxide. How about calcium? Will that need a Roman numeral, or is that a fixed charge? Well, let's see where it lives. Oh, it lives here in group 2. So we said that all of the group 2 metals are always 2 positive. So that is fixed. So I don't need a Roman numeral. What's NO2? Well, I know NO3 is nitrate. And again, as we learned in our lesson on polyatomics, this went from 3 oxygens to 2 oxygens. So when you lose an oxygen, you change the ending or the suffix to "ite." So this would be calcium nitrite. And our last one, Pb, that is lead. Will lead need a Roman numeral, or is it a fixed charge? Well, let's find it. Oh, it lives over here. It's not in group 1. It's not in group 2. It's not in the magic triangle. So it will need a Roman numeral. Well, what is selenium called? Well, selenium is just a nonmetal. So when it becomes an anion, we change the ending to "ide." So selenide. What's the charge going to be on selenium? Well, just like oxygen, it is 2 away from the noble gases, so it's going to be 2 negative. How many selenides do I have? I have 2 of them, so that's a total of 4 negative. So the cations must combine to be 4 positive. Got 1 of them, so lead 4 selenide. Well, I hope you enjoyed those practice problems on naming ionic compounds. As always, for more help on chemistry, come and visit me at getchemistryhelp.com, and be sure and click on the subscribe button so you can be notified as soon as new videos are posted. And we will see you next time. Thank you.